Hello! We're going to solve some problems of physics. I'm going to read the first one that it says two spheres, each with a charge of 3 times 10 to the 6, are separated by 100 millimeters, and that is 0.1 meters. Are they attracting each other? Determine the force between them. Okay, first of all, we have to multiply 1 over 4p epsilon 0, that it's 13 times 10 to the 6 times 3 times 10 to the 6. That is, of course, the charge of each of these small balls. So we're going to multiply this value, that is this, times our two charges. Of course, we put the 2 because they are the two charges, and over the distance, that is 0.1 meters. We multiply and just we pass this to the other side. We just multiply, and this is our final result, that is the force. And in this case, they are attracting.
Ajá, entonces pues estaría como chido de que dormirme toda la tarde, pero con él, o sea, pues X, no pierdo nada.
Problem number 2. Two small Cooper spheres of mass of 0.0180 kilograms are 50 centimeters apart. So imagine we have this, and here is 50 centimeters. The question is, how many electrons does each sphere contain? Remember that the copper atomic number is 29. So we're going to use this. The molar mass is 63.146. So we're going to solve this problem. Number 1, we're going to multiply 18 grams over the 63.146 grams over mole. That is our number. And this result we're going to multiply times the Avogadro number. And the result we're going to multiply times 29, that is the atomic number. So the first result is 4.94 times 10 over 24. And the second question is, how many electrons will have been removed from one sphere and up to the other, such that the attractive force is 3 times 10 square newtons is generated. Treat the spheres as point charges. These are our point charges. So we're going to multiply, and our result is this. The problem number 3, it says, a charge of 4 times 10 minus 6 coulombs placed at a point P within an electric field experiences a force it's equal to minus 8 times 10 to the minus 4 newtons. Determine the intensity of the electric field. So for electric field, we're going to use this formula, that is force over charge. So we are going just to divide, that is minus 8, that is our force, and our charge, that is 4 times 10 to the 6, and this is our result, and it's in newtons. Number D. An electron is traveling horizontally at a speed of 3.75 times 10 to the 6 meters per second and enters in an uniform electric field. What is the magnitude and direction of the electric field that uniformly stops the electron in a distance of 28 millimeters? How much time does it take to the electron to stop? Use the kinematic equations of Newton. Okay, so first of all, we are going to solve number 1, that is this. The electric field, that is 1 over 4p absolute 0, and we just multiply times minus 1.602 times 10 to the 18 columns. We're going to divide over 0.028 meters to the square, and this is our result. And it goes to the opposite direction because always the speed is it's opposite to the direction of the electric field in uniform. And our time is this. The problem number E says, applying Gauss law demonstrate that a field outside a charged solid sphere. Remember that Q is equal to the total charge over the sphere at a distance r from the center, has the following formula. In this, we just have to put the formula that it's this, that is charge, it's equal to 1 over 4p epsilon 0 times charge over radius squared. And it says that you have to justify your answer, and it is we use this formula because it multiplies the components. So because the Q is equal to the charge, and the R is equal to the diameter of the sphere. The number F says, how many excess electrons must be added to a plastic solid sphere that has a diameter of 0.26 meters to produce an electric field of 130 newtons over coulombs at the edge of the surface? Assuming the charge is uniform, what is the electric field at 10 centimeters from the center? Okay, we're going to use this formula. It's the same of this, but I just passed it to the other side, what we need, because in this time I need charge. So with the data we have, I'm going to multiply 130 over 0.26 to the square, and I'm going to divide it into our number that it's 8.98, 75, 51, 78, 7 to the 10 to the 9. And this is a constant, so remember this number we're going to use always. Okay? So my first result is the number of electrons, that it's this. And the second result that it's asking for the electric field is this, 6291.28 newtons over coulombs. Number G, it says a plate with positive charge is 0.05 meters higher than a plate with negative charge. And the electric field has intensity of electric field, it's equal to 5 times 10 to the 4 newtons over coulombs. Determine the work performed by the electric field E when a charge is 5 times 10 to the 6 coulombs and moves from the negative plate to a positive plate. Okay, so we're going to use this formula, and we're just going to multiply. That is this charge times this charge times 0.5 minus the two charges of the plates. Remember that one is positive and one is negative. So we're going to add and then subtract. And this is our final result of work. Remember there are joules. Find the electric potential at a point located at 0.05 meters of a charge of 8 times 10 to the 6 coulombs. Find the potential energy of a charge of 3 times 10 to the 9 coulombs that is located at the same point. Okay, so they are asking us for two charges. So first of all, we are going to get the first one, that we will use this formula. We are going to multiply the one that it's asking us times this result times our first location, that it's 0.05 meters. Then we are going to use the second formula, that it's volt is equal to work over charges, and volt is equal to 1.149 times 10 over 8 times 10 to the 6, and this is our result. Remember that it's in volts.